Hi, welcome to today's lecture. We're going to be talking about network programming using two classes, TCP Listener and TCP Client. The lecture comes out of Chapter 19 of my book, C# for Artists. Specifically, we're going to jump to page 560. This is the second edition. We're going to talk about, begin with the section on client-server applications with TCP Listener and TCP Client. So these are classes that are provided by the .NET framework, and you can get more information on them by going to the documentation. Here I've pulled up a window with the MSDN documentation. Okay, and that's the TCP Listener class. And the next class is the TCP Client. Okay. So these two classes work together. The listener, I'll usually just call it the listener. The listener is configured to listen on a particular IP address on a particular port, okay, for incoming connections. And if it's multi-homed, which is just a setting on the constructor, you can listen on all IP addresses on that server, okay, or a specific IP address if you've got more than one. Most machines do have more than one. They got localhost, and then they've got the IP address that's assigned to them. If they're part of a network, if they're just standalone, then you've only got the localhost IP address, which is 127.0.0.1. Okay, before you listen to this lecture, you should read Chapter 18, which is an introduction to networking, and that gives a lot of the background and terminology that I'm using for this particular lecture. Okay, so let's turn to the text first. The steps required to create a client-server application using TCP Listener and the TCP Client classes, essentially you'll have the server, okay, program. The server program and the client program will be two separate executable assemblies, first off. So generally, for the examples, I'll name one server and client, okay. The server will have the TCP Listener class utilized to maintain listening on the incoming, on the particular IP address and incoming port. The port number that you select should be free. In other words, there should be no conflict. Like, for example, if you're running MS SQL Server or Oracle, those ports that are used by those apps can't be used. Generally speaking, there's a lot of reserve ports too. I'm not going to go into them, but if you use 5000 or 5001, you should be pretty good. There's sites on the internet that you can check out to list the ports that are used by the various different Windows operating system and popular software that you've got installed. Obviously, if you got a web server up and running and you listen on port 80, then there's going to be a conflict. Like, for example, if you've got Apache running, or something else, the port 80 would probably not be a good idea. So some port that's free, not being currently used, and that's not normally used by any other commercial apps. Okay, so the TCP Listener then is started, essentially. We'll go into the details here in a second. And then it sits there in blocks using blocking I/O. Okay, until an incoming client connection comes in. The client connection is established with the TCP Client class, which is demonstrated over here on the right. Okay, so in this diagram right here. In the next diagram, once the incoming client connection is established by the TCP Listener, we're going to spawn a communication channel between the two, and we're going to pass off the handling of the communication between the two clients. So in other words, the TCP Listener when the incoming client connection is detected, the blocking IO unblocks, and a TCP client object is returned from the TCP listener object. There's a method called listen, I think it is. We'll go into that in a second. And then the two objects that communicate with each other are TCP client to TCP client. So the connection that is established flows between these two objects, okay? And if you've got a multi-threaded server, there's another video on threading, and you'll see some of the threading code for these examples. Most of these examples, except for the early ones, are multi-threaded. You'll spawn off this TCP client into its own thread, and then that lets the server get back to listening for incoming connections. So you can have more than one client connection connected to the server at any one time, and that would be called a multi-threaded server. Okay. And the third diagram here in figure 19-9, we have the TCP client. Now, information you actually read and write between these two TCP client objects using a stream reader and a stream writer. Okay, those are objects that you create that there's methods on the TCP client object that allow you to get the stream reader and get the stream writer, and then you can send information and read information back and forth. In order to communicate between a server and a client, there has to be some type of an established protocol, and as you, the programmer, are responsible for that protocol. Okay, and it's usually tit for tat. In other words, if I have a protocol that says as soon as I make a connection, I'm going to send the client some little handshake message from the server, then the client needs to then be ready to get that handshake message from the server and respond to the server to say, yeah, well, I'm ready to go. Okay, and then every other subsequent passage of information between the two has to be coordinated between the two. So as the programmer, it's your job to do that. It's not hard. You just have to know what state you're in this communication cycle. Okay, so we'll start with a simple application, and I call this Echo server and Echo client. So the Echo server code, which I'll pull up in Notepad++ here in a second, is just a server that listens for incoming connections. Okay, these incoming connections this is not a multi-threaded connection, or server, I should say. So it's only going to do one connection at a time. Okay, if you'll look at the code here, let me pull the code up. Okay, so server code. First off, we're going to be using the system namespace, system.io, system.net, and I don't think we're using .NET sockets, but I've got it in there anyway. Okay, so the first, I've just got one big class, public class Echo server, and then one big main method. Up on line 17, I create a TCP listener. Okay, I set it to null. And then in the body of the try clause here, in this try catch finally block, I create the listener, and if you'll see the code here, I say new TCP listener, and then I give it IP address.parse 127.0.0.1. That's one way you can send in the IP address. And then I'm listening on port 8080. Probably not a good idea to listen on that port, but for this example, it'll do. I know that on this machine, I've got no other applications running on port 8080. Okay, so then if you'll notice, I have listener.start. So soon as my listener is created, I call the listener.start method. And then I write a little message out to the console echo server started. And then I go into a loop. I go while true. So in other words, just keep repeating this while statement until it exits, until something forces it to exit. I say console.writeLine waiting for incoming client connections. And then the next line, line 24, I say TCP client. So I declare a new client, TCP client equals listener.accept TCP client. This method here, which is the listener that I created, at the beginning of this try block, the accept TCP client method blocks at that point, okay? And it's waiting for an incoming connection from a client, okay? Now for the client on the client machine, for the TCP client object that's configured on the client machine, when it tries to connect, it's got to connect to 127.0.0.1 port 8080. Okay, so this listener is listening on IP address 127.0.0.1 or localhost and on port 8080. So the incoming connection, once it gets connected, then the method unblocks and it returns a TCP client object. Okay. And then I write another line to the console, which says accepted new client connection. Next, I create a stream reader and a stream writer. And the way that I create these is, the stream reader and the stream writer classes are located in your IO, system.io namespace. So stream reader equals new stream reader, and then we're using this TCP client object that we just got from the incoming connection, client.getStream. So there's a getStream method, and we're using the same method on both lines to create the reader and the writer. And then on line 28, I create a string and I set it to empty, named S. And then in this while loop, I say while not S equals reader readline equals, okay? In other words, as long as this string comes in, right, that it's going to read from the client application, as long as that doesn't equal exit or null, then write to the local console, which is the server's aspect, right, from client, and then write the string. And then writer.writeLine, okay, writer.writeLine from the server. So now this is going to be written to the client. Writer.writeLine, quote, from server, end quote, and then concatenate the message or the string that was sent over from the client. Now, important is once you've written to the line or used the writer and the WriteLine method, you have to flush. This actually pushes it on its way across the network. So writer.flush. And then once everything is said and done, this will keep on repeating as long as it doesn't say exit or null. Reader.close, writer.close, client.close. You want to make sure you close all your connections when you're done with the program. Now, if there's any problems, obviously we'll throw an exception, and we'll just write that exception to the console. And then finally, okay, if the listener is not equal to null, we'll call listener.stop. Okay, and then we'll stop the listener. Now that's the server code. The client code is very similar. So now we're looking at the client code. It's kind of similar. It's not listening for incoming connection, but we have a echo client class with one main method, and we have a try catch block, and we create a new TCP client class on line 18. Okay, and we're saying, hey, we're going to connect to a port, connect to IP address 127.0.0.1 on port 8080. Then once I create that client, I'm going to get the reader and the writer by calling client.getStream, new stream reader, and then for the constructor, client.getStream. And I'm going to create a reader and a writer in that fashion. Then I'm going to create me a string variable called s, and I'm going to set it to empty. And then while s equals not equal to exit, okay, console.write, enter a string to send to the server. So it's going to, on the console, it'll say enter a string. You type something, hit return, okay, and then it'll set that to the string s with the console.readLine method. And then console.writeLine, just a blank line, and then writer.writeLine. Okay, so write to the write line, write to the writer your string that you sent, and then writer.flush. And then, as soon as I send that over, since on the server side, this is what I'm talking about protocol, I'm sending that over to the server, but the server is going to take it, write it locally to the console, and then send it back to me. So I have to say string, server string equals reader.readLine. So I know I just sent something to the server, and I need to get ready to read something because it's going to come right back. So I'm going to say reader.readLine, and then I'm going to write whatever that thing sent me back to the local client console. And then I, wrap up my program with, and this is just going to keep on going until I enter exit. Okay. Now reader.close, writer.close, client.close. Okay. And then console.writeLine. Now, let me see here. We need to run this program, and there's, looking at this code, there might be a little bit of problem I need to fix, but let's go ahead and run it first. Okay, so we'll minimize this window, and we'll pull up console window, and we're going to go to the source code for chapter 19, Echo Client. Go to the server first, and I'm going to change directories. Now, what I like to do is whenever I'm using client-server software, is I like to say start. So start Echo Server, and it should start up in a new line. Oh, we're going to compile it. So let's compile it first. Okay, start. There we go. Let me pull this over here. Okay, now we got the Echo server ready for incoming connections. Let me change the directory to this client software. Compile that and run it. Okay. So we got the server and the client. Now the server is just, it says when it started, it said Echo server started, waiting for incoming client connections. As soon as I started up the client, it connected, okay, and it said accepted new client connection. So now I'm going to send it a message. So I'm going to hit return. Now, in the server console, it said from the client, hello world, and then it sent it back. So it goes from the server, hello world. Okay. Now we can keep on doing this. Okay. Until the cows come home, essentially. Now if we exit, see what happens. Okay, so my client went away, and my server has returned to waiting for incoming connections. Now if I start another client, okay, it is ready to go. So all I got to do is send another message. Okay, now if I type exit, then client goes away, server stops, stops that connection between the client and the server, and returns to listening for incoming connections. Okay, and what I thought was a problem was not a problem, so all that code looks pretty good. Okay, so that's the first example. Okay, so to review kind of the basics, we got a TCP listener in the server app that's listening on a particular IP address and port. And on the client, we have a TCP client class object, okay, that has to connect to that IP address and port. And once that connection's established, the TCP client is returned from the accept method, okay, in the server code, and creates a TCP client. These two objects, TCP client and TCP client, communicate with each other. The way they do that is through stream readers and stream writers. Whenever you send a message to a client via stream writer, make sure you flush the output or the message won't get sent. Whenever, you as the programmer need to do the protocol, okay? So if I'm send something from the server to the client, or if I send something from the client to the server and I expect some type of response from that action, then I best be ready to handle that. And that's all the protocol means. So protocol is totally up to you. Okay. And that completes this section. Okay. Now we'll talk about building a multi-threaded server here shortly.